Hello students, today in this video we shall discuss about the reactions of alkenes. Okay, alkenes are double bonded unsaturated hydrocarbons having general molecular formula CnH2n. Okay, the general molecular formula for alkene is CnH2n, where n is the number of carbon atoms present in one molecule, and the value of n in case of alkenes is at least 2 or more than 2, 2, 3, 4, and so on. Okay, never less than 2, because alkenes are double bonded, so at least 2 carbon atoms must be present to contain this double bond, isn't it? At least 2 carbon atoms must be present to contain this double bond. So the value of n in case of alkenes is at least 2 or more than 2. Okay, now let us write the first alkene where the value of n equal to 2. Now we have the molecular formula for alkene is CnH2n, isn't it? So instead of n, I write 2, H2n means 2 into this 2. The value of n is 2, isn't it? So this will give us C2H2 to the 4. C2H4 is the first alkene, and the name of this alkene is ethylene. Okay, ethylene or ethene. This is the first alkene, and today in this video we are going to see the reactions of ethylene. Okay, reactions of alkenes. We are taking an example of ethylene. Okay, and the molecular formula for ethylene is C2H4, isn't it? The first reaction is addition of hydrogen. In presence of nickel or platinum as catalyst heated at 250 degrees Celsius, ethylene reacts with hydrogen to produce ethane. Now let's see the chemical reaction to understand this better. Okay, we know the molecular formula for ethylene is C2H4, isn't it? Now let us draw the structural formula. C double bond C. Here we have hydrogen in the four corners. Okay, so this is the structural formula for ethylene. C2H4, 1, 2, 3, 4. C2H4. We know that carbon is tetravalent element. It should contain 4 bonds to satisfy its valencies. Okay, so the valency or the bond of this carbon atom is 1, 2, 3, 4. Similarly, the valency of this carbon atom is also satisfied because it also contains 4 bonds. Okay, 1, 2, 3, 4, isn't it? Ethylene combines with hydrogen. Hydrogen means H2, so H single bond H, H2, H2, isn't it? H2 means H single bond H. Ethylene combines with hydrogen in presence of platinum or nickel catalyst. Platinum or nickel catalyst heated at 250 degrees Celsius temperature. Okay, ethylene combines with hydrogen in presence of platinum or nickel catalyst heated at 250 degrees Celsius temperature to produce ethane. Now let's see the product. Okay, so we have 2 carbon atoms here. Let's draw these 2 carbon atoms first. We already have 2 hydrogen atoms attached to this carbon atom, isn't it? H, H. Similarly, we have 2 hydrogen atoms attached to this carbon atom. So H, H. Okay. Now this hydrogen atom will attach here. Similarly, this hydrogen atom will attach here. Now we see the valency of this carbon atom is 1, 2, 3. So carbon atom contains 4 valencies, isn't it? So we put a single bond here. The valency of this carbon atom is also 1, 2, 3, 4. Now the valency of both the carbon atoms are satisfied. So this is a single bonded compound. Single bonded compound are called alkanes, isn't it? So alkenes combine with hydrogen in presence of platinum or nickel catalyst heated at 250 degrees Celsius to produce alkanes. Okay, and the name of this alkane is ethane. 2 carbon means eth, single bond means ane, isn't it? So this is ethane. Ethane is an alkane. Okay, now let me write the molecular reaction. C2H4 reacts with hydrogen in presence of platinum or nickel catalyst, Pt or nickel, heated at 250 degrees Celsius to produce alkane. Alkane is ethane. C2H6. C2H4 plus 2 is 6. C2H6. Okay. So this is the chemical reaction of alkenes. First chemical reaction, addition of hydrogen. Okay. Let us see the second type of reaction, addition of bromine. Okay. Bromine combines with ethylene in carbon tetrachloride solvent to produce ethylene dibromide. Now let us see the chemical reaction to understand this better. So we have ethylene here, C double bond C, hydrogen in the four corners. Okay, hydrogen, 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 isn't it? C2H4, 1, 2, 3, 4. This is the structural formula for ethylene, isn't it? Ethylene combines with bromine. Bromine means Br2. Okay, so Br single bond Br, and the catalyst used here is CCl4 solution. Okay, CCl4 means carbon tetrachloride. CCl4 solution. Now this bromine attaches to this carbon atom, and this bromine atom attaches to this carbon atom. Okay, so we have CH2, CH2. Let me write in this way: CH2, two hydrogen atoms. This one, CH2, another two hydrogen atoms. This one. Okay. Now this bromine atom attaches here. So we write Br here. This bromine atom attaches to this carbon atom. So we write Br here. Now the valency of this carbon is 1. So 2 hydrogen means 2, 3. 3 valencies are fulfilled. So we need 1 bond here. Okay. Similarly, the valency of this carbon 1, 2. 2 hydrogen means 2 bonds, isn't it? 2, 3, 4. 1, 2, 3, 4. Okay. So this is ethylene dibromide. Ethylene dibromide. Okay. Ethylene combines with bromine in presence of CCl4 solution to produce ethylene dibromide. Okay. Here also we can see the double bond of carbon. The double bond between carbon atom is reduced to single bond, isn't it? Now in this reaction, what happens is, in this reaction, red color of bromine decolorizes. Okay, red color of bromine decolorizes, which indicates that this hydrocarbon is unsaturated hydrocarbon. This indicates the decolorization of red bromine indicates the unsaturation of hydrocarbon. This reaction indicates that this hydrocarbon, ethylene, is unsaturated hydrocarbon. Okay, now let us see the next type of reaction. Okay, now let us see the third type of reaction, polymerization reaction. Ethylene is at first liquefied under a pressure of 1500 to 2000 atmosphere. When the liquid ethylene is heated to 150 degrees Celsius to 200 degrees Celsius in presence of chromium oxide as catalyst, a large number of ethylene molecules combine together to form a long chain molecule of polyethylene or polyethene. Okay, now let's understand this. Let's see the chemical reaction. Okay, CH2 double bond CH2. This is ethylene, isn't it? C2H4. 2 plus 2, 4. Okay, ethylene is a gas, isn't it? Gaseous ethylene is first liquefied by applying a pressure of 1500 to 2000 atmospheres. Okay, when this gaseous ethylene is applied pressure of 1500 to 2000 atmospheres, this gaseous ethylene becomes liquid ethylene. Okay, liquefied. It is liquefied. This gaseous ethylene becomes liquid ethylene. Now let's understand this. This is one molecule of ethylene, isn't it? Now if I multiply this with 2, this becomes 2 molecules of ethylene. If I multiply this with 3, this becomes 3 molecules of ethylene, isn't it? Now, a very large number of ethylene molecules becomes n molecules of ethylene, okay, where the value of n is very large. N molecules of ethylene, when heated up to 200 degrees Celsius in presence of chromium oxide as catalyst. N molecules of ethylene when heated up to 200 degrees Celsius in presence of chromium oxide as catalyst. This ethylene molecules forms a very long chain, okay, CH2 single bond. This double bond is reduced to single bond, CH2, and bond continues, okay, the chain continues, and the length of the chain is n number of chains, okay, ch2 ch2 ch2, n numbers, very long chain of ch2 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 continues. This is actually polyethylene or polyethylene, okay, polyethylene or polyethylene. N molecules of ethylene, n molecules of liquid ethylene heated at 200 degrees Celsius in presence of chromium oxide as catalyst forms a long chain of polyethylene or polyethylene. Okay, I hope you got this. The molar mass of polyethylene or polyethylene, same thing, okay, or polyethylene. Poly means many, ethylene, isn't it? ethylene. The molar mass of polyethylene or polyethylene is higher or much more than that of ethylene. Hence, polyethylene or polyethylene is solid, okay, polyethylene is solid, whereas ethylene is gas. Ethylene is gas and polyethylene is solid because the molar mass of polyethylene or polyethylene is much higher than that of ethylene, okay. Now, uses of polyethylene or polyethylene is uses. Polyethylene or polyethylene is used as common plastic to produce plastic items like pen, chair, packaging items, okay, etc. Polyethylene or polyethylene is used as common plastic to produce plastic items like pen, chair, packaging items, etc. Okay, this much for today. If you find this video useful, then please don't hesitate to subscribe the channel. I'll upload the reactions of alkynes in the next video. Thank you so much.